In this video, we're going to look at solving literal equations. Literal equations are simply equations that are typically made up of either variables or more letters and such rather than numbers. We see this a lot of times when we're dealing with formulas, distance formula, area formulas, volume formulas, whatever they may be. We eventually come to a part in mathematics where we need to solve for specific pieces of those formulas. So I just kind of want to jump into it. We're going to use the exact same methods that we would for solving a normal equation, but we're just going to solve it for something different. We're going to solve it for either another variable or maybe a letter, or as you'll see later in the video, specific shape. So I want to solve for A. Well, if I want to solve for A, that means that my goal is to get A by itself, right? So I want to get 3A by itself first. And I do that by subtracting B from both sides. Now, here's where it's just a little bit different. My 3A comes down, but C and B are not like terms, so I can't combine them. So I'm simply going to say C minus B. Now, I want to solve for A, so I'm going to divide both sides by 3. That goes away, leaving me with A equals C minus B over 3. Oftentimes, this is very difficult because we want to be able to simplify. We want to be able to solve it, but we can't here. C and B are not like terms, so just write them out following the operation that is being asked to do. So let's look at another one. So here, they're telling us to solve for x, so I want to get x by itself. The first thing that I need to do is I need to get the fraction 4 over x by itself, and I'm going to do that by getting rid of c. So I'm going to subtract both sides by c. That gives me 4 over x equals b minus c. And then I want to solve for x, so my next step is to multiply both sides by x. Now, when I do this, I want to put my b minus c in parentheses because we are multiplying everything on this side of the equation by x. So I need to make sure that I keep those things together utilizing my parentheses. So let's clean up our equation. That's going to cancel. I have 4 equals b minus c times x. So again, they want us to solve for x, so I need x to get by itself. Well, I can divide both sides. Since these two things are multiplying, I can divide both sides by b minus c. That's going to cancel, leaving me with x equals 4 over b minus c. So again, this can be very tricky if this is the first time you've seen these types of problems. But we're still following the exact same rules that we would for solving just a regular equation. Anytime we have two things here multiplying, we know that we can break that multiplication by dividing them. That's why I can take that whole term, b minus c. Okay? So let's look at another one. Here's the circumference formula. Circumference equals 2 pi r, and we want to solve for the radius. We want to solve for r. So I want to get r by itself. So since all 3 of these pieces are multiplying, what I can do is I can divide by anything that I want to go away. Well, if I want to get r by itself, I can just divide both sides by 2 pi. That's going to go away, giving me r equals circumference divided by 2 pi. And that's it. So again, this is kind of something that may be a little confusing. We can divide by more than just one term at a time, as long as they are multiplying. Okay, we can't ever break addition or subtraction, but since there is nothing adding or subtracting here, everything is multiplying, I can divide by multiple things. Let's try another one. For this problem, they want us to solve the equation for y. So that's a pretty easy thing for us to do. In order to begin with that, the first thing that I need to do is we need to move the 4x to the other side of the equation. Now, when I do that, it's very important for me to remember that 8 and negative 4x are not like terms. So what I have to do is I have to keep them as 8 minus 4x. We can't combine them because 4x has a variable and 8 does not. Therefore, we're just going to continue solving the problem out to isolate y. Divide both sides by 2, and we get y equals 8 minus 4x over 2. Now we can simplify this problem because 8 and negative 4 can both be divided by 2, giving us 4 minus 2x. And that is the solution to this literal equation, solving for y. Let's do another one. This one's kind of fun. I put this one in here because I want people to understand that it doesn't matter what the variables are, what the symbols are. Whenever we are solving literal equations, we are simply solving them the exact same way we would a normal equation. We're solving using the inverse operations to isolate whatever the variable they ask us to find is. In this problem, they're asking us to find triangle. So, in order to get triangle by itself, what I need to do is I need to multiply both sides by smiley face. Well, that's going to cancel, leaving me with 3 square plus 2 triangle equals 8 times smiley face. Go ahead, and again, we're trying to get triangle by itself. I'm going to subtract 3 square from both sides. I ask myself, is 8 smiley face and 3 square, are they like terms? They're not, so I can't combine them. So I'm simply going to write my equation as 2 triangle equals 8 smiley face minus 3 square. Final step, get triangle by itself by dividing everything by 2, and we wind up with triangle equals 8 smiley face minus 3 square divided by 2. Now we can simplify this problem a little bit further. I can divide 8 smiley face by 2, but I can't divide negative 3 square by 2 cleanly. So what I'm going to do is I'm going to divide just the 8. 8 smiley face divided by 2 is 4 smiley face, but then we still have minus 3 square divided by 2. And there's the solution for that literal equation. So I hope these videos, or this video rather, has really helped you figure out that literal equations are the exact same as just solving a normal equation. There's no different. You are just doing the opposite operation to move your term to the other side of the equal sign so that we can isolate and solve for our variable. Thanks for checking out the video. I hope it helped. I'll see you next time.